Hey guys, today we're going to be talking about spheres. We will be calculating the surface area and volume of spheres. But first we're going to look at some of the parts of spheres. Many of these are very similar to how we would think about a circle. So the locus of all points in space that are a given distance from a given point. Well, this is the definition of a sphere. So the sphere is made up of all the points that are a same distance away from our center. So a segment from the center to a point on the sphere. Well, anything that connects the center of the sphere to a point on the sphere, just like in a circle, is a radius. So we can say right here, we see that this is a radius from our center out to the side of the sphere. A segment that connects any 2 points on a sphere. So just like in a circle, when we had a segment that connected points on the circle, if it connects points on the sphere, this is our chord. So we'll write chord up here. A chord is a segment that connects any 2 points on a sphere. Now, specifically, a chord that contains the center of a sphere. Well, a chord that contains the center, just like in a circle, is a diameter. So go over here and label. We see that this chord goes through the center. So this is a diameter. And our last one is a line that intersects a sphere in exactly 1 point. Well, similarly for a circle, a sphere can have a tangent. So a tangent is a line that intersects a sphere in 1 point. That is our tangent. Okay, now we're going to look at the surface area formula for spheres. So surface area, that's again that area around the sphere itself. The surface area S of a sphere is S is equal to 4 pi r squared, where r is the radius. So what I want you to notice is that it's 4 times pi r squared. Well, remember, pi r squared, what is this? That's just the area of a circle. Okay, so we're just looking at multiplying the area of one circle by 4 will give us the surface area of a sphere. So let's look at our first example. So we see in this example, we are given a radius of 6. We're going to plug into our surface area formula, 4 pi r squared. So our surface area, we plug in our 6 pi times 6 squared. Now notice it asks us to leave our answer in terms of pi. So what that means we're going to do is we're going to plug in our calculator. We're going to say 4 times 6 squared, and we get 144 pi. And our units here were centimeters, and since we're talking about area, that's centimeters squared. So surface area of this sphere is 144 pi centimeters squared. Looking at the next example, here we see that we were given a diameter. Now this diameter is 22 feet. So if we want our radius, we know our radius is just half of the diameter. So our radius would be 11. Now we're going to plug back into that same surface area formula. Surface area is 4 pi r squared. So the surface area is 4 pi times 11 squared. And again, because we're giving our answer in terms of pi, we are just going to plug in the 4 times 11 squared in our calculator, and we get 484 pi. Our units here were feet, so we have feet squared. Now, let's talk about how we would look at how to find a hemisphere. So first of all, we'll talk about a few of these little vocab words here. If a plane intersects a sphere so that the circle made includes the center of the sphere, then it is a great circle. So we know that if we were to put planes inside cutting this sphere, that it would make little circles every time a plane cut through it. And when we put a plane that goes through the center of the sphere, This circle that is made right here is called the great circle. So the circle around the middle is that pi r squared circle, and then that is called the great circle of the sphere. A hemisphere is half a circle, and it has a base that is the great circle. So when we look down here at example 2, we are finding the surface area of a hemisphere. So first of all, let's look about what we are looking at in our picture. So I'm going to say that we are going to find the surface area, and I'm going to use a little subscript h to talk about the hemisphere. Well, when we look at this hemisphere, we see that we have the area of the dome. So I'm going to say the dome plus, then we have the area of the great circle that it is sitting on, right? Because it's got the base, that's the great circle. So I'm going to just say add the base, which we know here is the great circle in this cylinder, in this sphere. So now let's talk about what do we know these things are. Well, the dome part of our sphere is just half of the surface area of the whole sphere. Okay, so our dome part is going to be the surface area of the whole sphere divided by 2. And then the area of the great circle is just pi r squared because it's the area where the radius is the full radius of our circle. So when we look at this and simplify, we see that 4 pi r squared divided by 2 simplifies to 2 pi r squared plus the 1 pi r squared, that's the great circle. So the area of a hemisphere can be found by doing 3 pi r squared. So let's go back to this picture. We know that we need to find the area of the hemisphere. So the surface area of the hemisphere, we're going to say is 3 pi r squared. Well, we know here that we have 3 pi times 2.8 squared. And when we plug this into our calculator, we're going to leave our answer in terms of pi. So again, we'll just plug in 3 times 2.8 squared, and we get 23.52 pi centimeters squared. That is the surface area for our hemisphere. Okay, now we're going to look at example number 3. This time we're being asked to find the surface area of the sphere, but we're not given the radius. We're given that the area of the great circle is approximately 130 inches squared. So we're still going to leave our answer in terms of pi. But again, let's go back to that surface area formula. Surface area is equal to 4 pi r squared. Now, if we think back to what we talked about a second ago when we learned about great circles, we know that this right here, the area of this circle, is the same as the area of the great circle because the great circle has the same radius as the sphere. So when we're given the area of the great circle, we can just plug that in for the area or the pi r square part of our formula. So here our surface area is just going to be 4 times, well, we know that the great circle is 130 inches squared. When we plug this into our calculator, we get 520 inches squared. So even though this seems like a little bit harder problem because we weren't just given the thing to plug in, this actually is easier. So whenever you're given that area of a great circle, know that the area of the great circle is that part, that pi r squared part of our formula, and all we have to do is multiply that great circle area by the 4 for the surface area formula. All right, now we're going to look at the volume of a sphere. So the volume V of a sphere is V is equal to 4/3 pi r cubed, where r is the radius of the sphere. Now, a couple things to notice. Notice that from our coefficient of 4 with surface area, Now we have a coefficient of 4/3. And the other thing to notice about this formula is notice that our r is no longer squared, our r is cubed. Because when we're talking about volume, we're talking about the 3 dimensions of this figure, what takes it to fill this sphere up. So that's why we have r cubed. Now, we're going to first look at the volume of a hemisphere. Now, we can think of the volume of a hemisphere. It's a little bit easier than thinking about the surface area of a hemisphere because here we're just talking about how much do we need to fill it up. So when we're taking how much we need to fill up for a hemisphere, it really is just half the volume of the sphere. So I'm going to say that the volume of the H hemisphere is equal to 1/2 the volume of the sphere. Okay, so now we need to find the volume of the sphere first. So the volume of the sphere is equal to 4/3 pi r cubed. So when we plug in our r in this situation, we have a radius of 6 meters. So 4/3 pi 6 cubed. We're leaving this in terms of pi. So in your calculator, you would say 4 divided by 3 times 6 to the 3rd, and the volume of our sphere is 288 pi meters cubed. Because again, remember when we're talking about volume, our units are cubed. Now, we're going to go back over here, and we know that the volume of our hemisphere has to be half of that. So the volume of our hemisphere is 1/2 the volume of our sphere, 288 pi. And when we take half of that, our volume is 144 pi meters cubed. Now let's look at the next one. It says, find the volume of a sphere if the great circle has a circumference of 18 pi. Now remember, that great circle is just kind of the circle of our sphere that goes through the center. So we know that whatever we can find for the radius of the great circle will also be the radius of our sphere. So we know that it has a circumference. We know that formula is 2 pi r. So our circumference here is 18 pi. We're going to set that equal to the 2 pi r so we can solve for the radius. Well, our pi's cancel out. We have 18 is equal to 2r. So we divide both sides by 2. So here we get that 9 is our radius. So now I know what the radius of my sphere is. I'm asked to find the volume. So now I'm going to just plug into our volume formula. 4/3 pi r cubed. So the volume is 4/3 pi times 9 cubed. We would plug in 4 divided by 3 times 9 to the 3rd, and we would get 972 pi centimeters cubed. Now for our last example, this time it wants us to find the circumference of the sphere if its volume is approximately 8.65 inches cubed. Leave our answer in terms of pi. Now, the circumference of the sphere is basically going to be the same as the circumference of the great circle, right? Because the circumference of the sphere is the length around it at its widest point. Now, this time, we're looking for that 2 pi r, but we've been given the volume is 8.65 inches cubed. So what we need to do is we're going to plug in our volume into our volume formula, 4/3 pi r cubed, and we're going to work backwards to solve for r. So we're going to plug in our 8.65 for our v. 8.65 equals 4/3 pi r cubed. So now our only unknown here is the radius. So we need to just plug into our calculator. I don't know what 4/3 pi is, but we're going to plug it into the calculator. And when we do, we get 8.65 is equal to 4.19 r cubed. Now, to get the r by itself, first I have to get the r cubed by itself. So I'm going to divide by 4.19, both sides by 4.19. And I get 2.06 is equal to r cubed. Now, to undo a cube, we know we need to take the cube root of it. We can also do that in our calculator. You can hit the math button, and math button will give you a drop-down menu, and you'll have a cube root option. And so r is equal to 1.27. But again, we didn't need to know the r. We want to know that circumference. So circumference is equal to 2 pi r, or circumference is equal to 2 pi times 1.27. We're going to leave our answer in terms of pi, which means we're just going to multiply the 2 and the 1.7, and we get 2.54 pi inches. And again, it's just inches because it's just that one-dimensional length around the sphere. So the circumference here is 2.54 pi inches.